Welcome to Landmark Learning. In this video, we will discuss how to model fractures inside NETool. We start with a simple horizontal well, and first we create completions in it and specify perforated intervals. After that, in global settings, we specify fractures feature, and in well target IPR, define our production schedule, simulation duration, report interval, and bottom hole pressure as a function of time. After that, we go to segment settings, reservoir parameters, and define that at every perforated cluster we have a fractured zone. Fractured zone means that the interval around that perforation is hydraulically fractured. NETool allows to specify fracture parameters such as length, height, width, spacing, propant properties, fluid in place, permeabilities around individual fracture, porosity, and saturations. So this is a well-centric approach to reservoir modeling, where we define properties around the wellbore. When model is defined, we run simulation, and NETool starts transient modeling of the flow inside this well with 8 fractures. So it's using all available CPU cores, and simulations are usually pretty fast. When simulation is complete, NETool produces production rates of the well as well as bottom hole pressures for the duration of the simulation. So, for example, this is our oil production, pressure at the first node, and cumulative rates, where we can investigate our oil influx into the well through these fractures. This model is not replacing reservoir simulators and is intended as an intermediate solution between full-scale reservoir modeling and simplified production decline curves, which usually don't work for condensate reservoirs. So what NETool actually does here, it creates a two-dimensional grid around every fracture, with multiple fractures connected through the wellbore, and then models flow in this domain between the fractures and from the extended reservoir into the fractures. It accounts for PVT properties of the fluids and models pressures and flow rates inside these grid blocks. So eventually it's using the same equations as full-field reservoir simulators, but in a simplified domain. The main application of this feature is sensitivity analysis for number of fractures and fracture parameters. For example, I can run the same well with 4 and 8 fractures and see production decline over time. As you can see here, the well with 8 fractures is declining faster than 4 fractures, and probably means it's less economical. The limitation of the model is that it is one well only, and there is no possibility for aquifer or gas cap drive. So all the production is driven by expansion of the fluids in place. Thank you for your attention.